energy loss around 20% is happening in your air handling units, air handling blowers of your HVAC systems in the decade old commercial buildings as well as in the industries. Let us look in depth. The existing running AHU blowers in your decade old buildings and industries have only forward curved impeller instead of a backward curved impeller. During our energy audit case studies, we observed many of the AHU are having only a forward curved impeller instead of the backward curved impeller. You can just open up your blower casing, visually inspect it, and for the orientation or refer the blower nameplate. What do you have in your system, in your HVAC system? Previously, the forward curved impellers were procured because of its low cost and the size, small in size. And now, when do you plan to replace your forward curved impeller with the backward curved impeller? This is the need of the day now, because almost 20% energy savings is possible in this swapping from forward to backward curved impeller in your blower system. The new blower housing with backward curved impeller will be bigger in size as well as in cost. It's costly also, I agree, but still it is worth doing it because the 20% energy savings is very much possible. In the energy efficiency improvement is possible in the newly installed backward curved impeller blower. The energy efficiency is around 20% higher, and you can see the types of backward curved impeller. You can have a curved impeller or a flat impeller, backward curved impeller or a backward flat impeller, and the most efficient is the aerofoil type impellers, and this is more efficient. And now the plug type impeller that has become the it is also coming in a big way in all the HVAC segment now. Let us revisit the Bureau of Energy Efficiency table below. The blower impeller types which give the peak efficiency range. Everything is detailed in this chart below, and you can calculate your static fans efficiency as per the below formula as given by the Bureau of Energy Efficiency, and you know where do you stand, especially when you are running your existing blowers. The fan static efficiency equals to almost the volume in meter cube per second multiplied by the static pressure that is developed in your blower in mm of water column divided by 102 into power input to the blower shaft. Here I am mentioning power input to the blower shaft only, it is not the motor output shaft power. There is a difference because of the coupling that happens between the motor and the blower. And normally the blower is efficient if it is around 70% practically. You can see the centrifugal fans, the aerofoil, backward curved impeller and inclined almost 79 to 83%. And the last in the row you can see the forward impeller, it's around 60 to 65% only. And when you see the graph of efficiency versus the flow rate, you can see the forward curve is at having the minimum efficiency, and the backward curve is having the maximum efficiency, and it is topping the table with aerofoil, that is the most energy efficient backward curved impeller, inclined impeller. Coming to the pictorial representation of the centrifugal fan blade design versus efficiency in this impellers design and orientation. You can see the backward curved impeller at 79%. You can see the picture of backward curved impeller, and you can see the third picture as forward curved impeller, that is only 60%, and that is almost around 80%. The aerofoil blades almost it's around 80%, which is more efficient. So each of the impeller design as given by the Bureau of Energy Efficiency energy details of all the blowers. What is your impeller type and efficiency, and what is your fan performance curve and characteristic as given by your OEM, and if not if you are not having it recorded, you get it recorded from your OEM as apart from the nameplate specs of the blower. Nameplate specs give only the basic data, whereas the fan performance characteristic or the curve that gives a full detail about the your blower spec. It is a case study of a blower of the same branded blower with forward curved as well as backward curved impeller. The static efficiency calculations stand like this. You can see the backward curved impeller is efficient by more than 20% than the forward curved impeller. The same branded blower is around 7.5 HP at a flow rate of 6400 CFM and a static pressure of 65 mm water column. The static efficiency delivered is only 40% because it is forward curved. The same branded blower, but it is backward curved, but the motor size is different. It is okay, we are just comparing the static efficiency of the same brand between the forward and backward. You can see the 7.5 kilowatt motor and almost 15,900 CFM is the delivery at a static pressure of 60 mm water column, whereas the static efficiency on calculation it shows around 65%, the static efficiency. And comparing to the other old brand, that is a forward curved blower, same 7.5 HP, it delivers only 9600 CFM at 40 mm water column only at a lesser static pressure, whereas the same other branded backward curved impeller, same 10 HP blower at 1440 RPM, airflow is around 18,000 CFM at 60 mm of water column. You can see the static efficiency difference of 38% to 74% here. This is the focus area when you are trying to replace your blower with a forward curved impeller to the backward curved impeller. The efficiency improvements is the more critical for you to achieve now in the your air circulation area. It is not only in the buildings, it is happening in the industry also. Refer the nameplate specs and open your blower casing and check its impeller orientation today. Industries normally they have most of the industries they have backward curved impellers only because the environment also matters more. So backward curved impeller suits more. But still you just check from your end what is your type, what you are deployed in your plant. HVLS, high volume low speed fans, that is need to be the focus here. Maximize the volume of impeller air throw in the blower at a lesser speed, and this type delivers more efficient like a similar HVLS ceiling fans. Though operated, most of the blowers, 90% of the blowers are operated in 4-pole motor only, and the blowers are more efficient when they are operated, when the blower shaft is operated around 800 to 750 to 800 or 900 RPM, less than 1000 RPM. Blowers are more efficient. You can see the curves of the backward curve. Here I just wanted to highlight what is the difference between the backward curve and the backward straight or a backward flat designed impeller. You can see the efficiency difference of almost from 84% to 78%. This is what many of the industries of the say around a decade old industry, they have gone for a backward straight impeller. They can go for backward curved impeller with a higher volume and better efficiency, and they can achieve around 6 to 10% is possible in this backward curved impeller change swap itself. You can see the forward, you can also see the visualize the forward curved impeller, the direction of flow as well as the impeller orientation compared to the backward curved impellers. Typical airflow diagram from AHU to the user premises in an IT buildings. Routinely monitor the static Pascal at blower delivery and across the filters. The delta P across the filters needs to be monitored. What is the normal static pressure to be maintained, and what is, whenever it is going high, it needs to be a part of your building management system. Because IAQ, internal air quality, is becoming critical now. That is the focus area. Many of the IT buildings, and CO2 sensing, closed loop automation, it is becoming the order of the day, and air circulation is centered around maintaining the IAQ of the given IT buildings now. Static pressure in a centrifugal blower or axial flow system, this is not only applicable to the centrifugal blowers, but it is also applicable to the axial flow fans. The system resistance is referred here as the static pressure. This system resistance is the sum of static pressure losses in the system. The system resistance is a function of configuration of the ducts, pickups and elbows and the pressure drops across, and it varies with the square of the airflow from the blower. So the long narrow ducts and short bends give more resistance and heavy pressure drop, static pressure drop, and the large ducts and few bends and longer bends with less system resistance or less static pressure drop across the flow layout. In practices, the blowers are normally operated around 60 to 80% loading. That is what we have observed during our energy audits. Know your blower fan performance curve and you know with the system effect what is the fan performance characteristic, so that you can operate your blower at its best efficiency point in practice. These parameters are recorded during your blower commissioning installation report, and you can discuss with your OEM and get back to the commissioning installation report, and you can analyze the fan performance characteristic here. So you can see for the given axial flow rate in the x-axis, the static pressure in inches of water column, say a system curve as calculated, it shows around 14,000 CFM at 10 inches of water column, but with the system effect, with the system resistance that is included in the system curve, actually you find the 14,000 RPM has dropped to almost 12,000 RPM, and the static pressure has gone up from 10 inches to 14 inches. So this is the area you have to focus from end to end, from the blower end to the user end, delivery end. All these case studies have been explained in these books, Practical Guide to Energy Conservation and Management and Energy Monitoring in the Residential and Commercial Buildings. And in these case studies, whatever we learn from these case studies, we try to deploy it in our buildings or in industries and make the energy savings as fast as possible now. That is the need of the day as such. So sharing the knowledge to save our energy energy is common to all, and sharing the knowledge to save our energy, that needs to be the motto now. Thank you, thank you, thank you.